So, continuing with the cleaning of insulators in energized condition, this involves various methods and techniques which are discussed earlier. So, helicopter based methods, nozzles which are being employed are particularly used for very high voltage transmission systems in EHV and UHV ranges, and this many of the times where it is difficult for the transport to reach, like a truck mounted arrangement in such cases, and the tower situated at the high altitude regions, mountainous areas. So, in places where the land route is difficult, in such cases helicopter based arrangement for cleaning are being employed by the utilities in India as well as in several other countries. So, this picture as we were looking into sees how the cleaning of insulators are being done for a single string or a double tension or a quadruple type of arrangement. So, as mentioned earlier, in case if the stringing arrangement of the tower is a V type of insulator, here it should be noted that the cleaning has to be performed from the two sides, so that the contaminants does not carry from the side which is being cleaned to the other side which is not being done. So, proper cleaning methods have to be planned and then executed in case of the V type of arrangement. In tension mode and in suspension mode, this difficulty will not arise, as the contaminants will be washed away during the nozzle arrangements where it is directed from a distance as we discussed. So, this about the live line techniques which are being employed. So, there are methods in case of the de-energized condition, or the supply is being switched off and the maintenance is being done for the cleaning purpose. This involves various methods, again techniques during the de-energized condition where supply is not there and where equipment is taken up for maintenance. Here the requirements of water resistivity are similar or same as for the energized conditions, like the resistivity and the conductivity of water does not change whether it is energized or de-energized conditions. However, the point is the clearance issue is not there, whereas in energized conditions or the live line washing we have to maintain a minimum clearances for the cleaning purpose. Here, as the system is de-energized, the cleaning portion which is being carried out, the clearance is not a serious issue. So, thereby allowing different washing conditions from the methods which are being used. So, here again various methods are being adopted for the cleaning. We will discuss some of the methods and the techniques which are used for the de-energized situations. One is the hand cleaning. It is basically the cleaning of insulators by the hand, wiping it thorough and effective on the insulator surfaces, removing the dirt and the pollutants which are spread on the surface. But it is a tedious job, time consuming and also expensive process which requires lot of equipment outages. So, the outages or for the maintenance, the time which is taken out or the de-energize of the equipment is being taken requires long process of time and also a tedious job. So, hand wiping in generally is used only when washing is impractical because of problems of access by heavy vehicles, or it could be because of the height or a design of a particular structure or a type of contamination. So, in such cases hand washing is recommended, and hand wiping is normally used on station insulators, that is in substations where high pressure washing is either impractical or due to proximity of energized other equipments in the system. So, it will be difficult to completely de-energize the entire substation and take for maintenance. So, in such cases because of the proximity of other equipments which are nearby the insulators to be cleaned, in such cases hand washing is preferred or where other methods are difficult to be used or ineffective due to sometimes hardness of the surface deposits. If surface deposits on the insulator surfaces, it could be on the post insulator or any of the bushings where normal washing by the pressure washing could not be cleaned. In such cases this hardness of the material deposited had to be used by the hand cleaning methods. So, some insulators can be cleaned only using soft or dry wiping rags. In some cases you may require hardness of the surface to be removed. So, additional materials such as wet or paraffin soaked cloth. Here various methods have been formed, few of the things are being discussed. So, some are wet or paraffin soaked cloth, solvents, sometimes steel brushes, again all this cannot be generalized and these things cannot be used for all type of insulating materials. So, particularly the steel brushes or steel wool which may be needed for some of the insulators cannot be used for the polymer insulator which is of soft. So, care has to be taken by mentioning this depends on the surface conditions and the material to be removed, the hardness of the material which is deposited on the surface. So, such materials are being used to clean the insulation or bushings or substation equipment where these insulators are being housed. These are some of the practical conditions where de-energized cleaning is being carried out. You can see here in case of tower or in case of the tower arrangement for a single suspension string, the utility people physically clean the insulator by the hand washing methods which over a period of time the contaminants accumulate on the surface, become hardened. So, here proper measures have been taken, the supply is switched off and necessary grounding is being done. Based on that the cleaning of insulator is taken up and the surface which the pollutants make it hard has to be removed and takes a longer period of time. So, this is one of the example which is being carried out the cleaning process on the insulators using the de-energized method. This is again a different one of the other method which is being done, particularly handheld water jet of known spray is being targeted to the insulator surface. Both on the surface as on the petticoats the cleaning is being done to the insulators in the de-energized conditions. So, you can see the as mentioned the water resistivity, the solvents, all this which are being used also play a role in cleaning aspects. So, this is one more example in the substation where the bushing of the equipment, it could be a current transformer or a lightning arrestor, bushing of the ceramic disc is being maintained, cleaned using a handheld water jet here. So, various methods are being suggested for the cleaning purpose during the de-energized condition. These are few of the practical methods which are being employed. So, several others as mentioned either using the dry cleaning method, using a plain cloth, or if the hardness is more, the hardness is being removed with the help of solvents or liquids which can be used to clear the pollutants on the surface. So, very important, this cleaning has to be carried out else you can physically see this gets over a period of time and the creepage reduces and the flash over of the string happens during the monsoon conditions where it is unwarranted or unwanted for the power system utilities. So, necessary procedures, necessary plan and regular periodic maintenance is essential. So, different methods either in energized or de-energized conditions have to be carried out. So, again various types of equipment, materials are being used. So, we will look into some of the utilities where they use various methods for cleaning. We go for the non-abrasive nylon pads, where these nylon pads of non-abrasive in nature are used when the cloth or paper towels are ineffective. In case the hardness which is on the insulator surface is difficult to clean with normal cloth or paper towels. In such case, to remove the hardness hardened pollutants on the surface of the insulators or on the bushings, non-abrasive hard type of nylon pads are being employed by the utility personnel in removing the contaminants or the deposits. It could be from the cement industry's example. So, such cases cleaning with an ordinary cloth or a paper towel may not be effective. In such cases, high non-abrasive type of methods are being used. The second is the steel wool. Again, steel wool is sometimes used when the cloth or the rags or the paper towels of or nylon pads. In such cases, even nylon pads do not be effective. In such cases, steel wool is being employed. The caution again is to be maintained and exercised to see that it removes all the metal particles left by the steel wool. That is very important. This small particles which from the steel wool if deposited on the surface of insulation could lead to the early breakdown of the surface. So, care has to be taken once the cleaning is being done. Any traces or metal particles which are left on the surface of the insulators have properly to be completely cleaned after the cleaning is done to check whether any metal traces are left over. The third is the solvents. Solvents again as mentioned earlier, this may be used in aiding the cleaning sometimes when this may help for better cleaning. So, care has to be taken particularly with strong cleaning agents because of fumes or residue. So, some solvents may cause fumes or the residue which may left on the surface could again cause problems to the surface of the insulators. So, picking the solvents is also an important aspect for cleaning. So, after cleaning with the help of the solvents, the insulator should be rinsed with clean water to remove any residue which is being left by the solvents on the surface of insulators. In case of polymer strings or insulators, in general no solvent can be used. This is an important point to be considered and particularly unless it is advised by the manufacturer. So, polymer insulators again I am stressing here, these are of organic in nature. The rubber surface of the sheds, in case of using the solvents, they chemically react the surface and this could degrade the hydrophobicity characteristics of the rubber surface. So, solvents, steel wool and non-abrasive type of methods should not be employed for polymer insulators unless there is a direction from the manufacturer to which method or which solvents to be used for the cleaning of polymer insulators. So, care has to be seen, not like the ceramic or a porcelain or a glass insulator. In case of polymeric insulator, the general methods cannot be used. So, how the results of cleaning, this is an important decision has to be taken by the personnel or the technicians who do the cleaning for the insulators, how to check the efficiency of the cleaning or the results of efficient insulator cleaning, and this can be judged by the following ways. One is the visible through the naked eye where the surface should be very clean and it should be shiny. So, once the surface conditions of both top and bottom of the insulator petticoats or skirts should be visually clean and shiny after the water or solvents have dried. So, care has to be checked, seen that in case there is some residue left on the surface after cleaning, and if the surface is not clear, you can spot some of the patches on the insulator surface So, this is not proper cleaning. So, proper cleaning has to be made, so that insulator is completely after dry looks visibly clean and gives because of the, in case of ceramic insulator, the glaze shows the shiny appearance. This has to be observed. Second is the insulator vibration or a ringing sound. Here again the mechanical vibration or ringing of insulator skirts, particularly the petticoats or the sheds, which we call for the porcelain insulator, under impact of high pressure washing and exhibiting evidence of efficient swirling cleaning action. So, this based on the experience, the personnel or the technicians could feel the vibration or the noise of the high pressure washing on the surface or on the sheds of the insulators. So, this could also be noticed during the high pressure washing for efficient cleaning action. The third is the absence of corona activity. So, here because of the contaminants on the surface, it could be a metallic parts, it could be the hard dust comprising of a conductive dust which settles over a period of time because of the fog or a mist, where the activity of corona starts on the surface, showing dry band and wet band and arcing partial discharges and also corona discharges, which could extend from the metal cap to the porcelain pin to the cap of the insulator, depending upon the surface conditions during energized conditions. So, here the corona, if it is during the energized condition, so it should be noticed that the blue corona discharges which extend from metal cap to the porcelain at the energized high voltage washing may be heard for few seconds after completion of the cleaning aspects. So, once the insulators are completely clean, the discharges have to be reduced. So, if this discharge in case continues for more than a few seconds and even after the insulator is completely dried, this may indicate incomplete washing of the insulators, in which case the wash stream should be reapplied, that is an indication. So, once the cleaning with the high pressure washing is done, corona activity should completely die down or completely disappear. In case if activity persists, this is an indication of the insulator requires more cleaning method or the better cleaning method to see the corona activity is not there on the surface. Then clarity of runoff. So, importance of this is the clarity of the water runoff may also indicate the effectiveness of contamination removal. So, once the insulator the contaminants which are spread or pollutants which are spread on the surface are removed, then water runoff may indicate the effectiveness. Here again the clarity of water runoff may be very difficult to observe because of the distance. Sometimes when the utility personnel are operating or cleaning this from a distance, it is very difficult to physically observe and see this. So, wearing during sunlight also it is difficult. So, wearing of sunglasses or looking through the binoculars could help to see the clarity of the water runoff, which indicate the effectiveness of the contamination on the insulator surface. The other is the water quality. Here again the quality of water is important, which is being employed for the cleaning purpose of on the surface of insulators. So, water of high resistivity or low conductivity, very important, should be utilized in cleaning the energized insulators or the de-energized insulators. Rainwater or snow melt water and steam plant water, which distillates are known in general to have good resistive characteristics. So, this type of water can be used for cleaning purposes. The constant testing of water being used is also equally important. The resistivity and conductivity is to be monitored, so that hard water is not being used for the cleaning purpose, where this again deposits, and which could again which may not be properly used for cleaning. So, the water quality is of utmost importance. Similarly, resistivities can quickly change due to temperature also. This point has to be considered. So, water of poor resistivity which is in the range of 750 ohm centimeter to 1000 ohm centimeters, that is 295 ohm inch to 394 inch, can be purified by deionizing systems or by filtering. So, in case the places where high resistivity or low conductivity water is not available, in such cases the water has to be purified by using a deionizing systems. Later on, this purified or deionized water is generally employed for the cleaning purpose. So, the minimum water characteristic should be determined based on planned operating practices and also for the expected voltages. So, this characteristic can be determined based on various practices which are being employed and also for the voltage levels which is being used. So, the resistivity greater than 1500 ohm centimeter or 590 ohm inch is generally desirable to use for the cleaning purpose. The recommended values: in freezing conditions or cold conditions, water resistivity should exceed 50,000 ohm centimeter or to 20,000 ohm inch for the cleaning purpose. So, these are the some of the broad guidelines pertaining to the quality of water and the resistivity of the water and the usage for the cleaning systems, particularly for any insulators or the substation bushings or equipments which are housed using those. The further is the additives for the water. What are the various additives which are being used for the cleaning of the insulators. So, water quality and the resistivity we have discussed. So, additives, no soaps or detergents should be added to the water. This is a point to be considered. The soap solution or the detergents which are used for cleaning will again leave deposits on the surface if it is not properly cleaned or washed. So, soaps or detergents should never be used for cleaning. Generally, cleaning is accomplished by the impact of water and rinsing the water. So, in countries of northern and Arctic climates, no antifreeze or alcohol is to be added, alcohol is added here because the flame danger and residual contaminants and environmental consideration eliminate their use. So, no antifreeze or alcohol is added. So, alcohol or soaps or detergent should not be employed for the cleaning, as this may cause the danger or the flame or the residual contaminants could have a discharge activity or the arcing could be seen. So, the water which is warm but not very hot will generally remove the contaminants of the oil contents and so on. And although freezing will occur as the ice or frozen contaminated water melts, contaminations will generally be flushed away. So, in such cases the ice should not be left bridging the air gaps between insulator sheet. This is to be noted. So, while removing with the hot water or a warm water, care has to be seen that the ice which is being frozen on the insulators have to be completely melted, removed, and between the petticoats or sheds or the air gaps between the sheds, it is to be verified that there is no bridging which is happening, as this bridging between the sheds will bring down the creepage length of the creepage distance of the insulators or the insulator. So, proper cleaning in case of the fog deposits or the freezing conditions have to be done. Additives for polymer or polymer type substances can be added to water. So, these polymer type substances which can be used to focus the water stream more like the water alone. So, the mix of the polymers could be used in the water to clean it. generally increases the amount of pressure available at the nozzle and allows for more effective jet of water farther from the nozzles. So, some substances related to polymers can also be used. It is most effective particularly when these are used during windy conditions or high windy situations, or when wash distances exceed the reach of a normal water stream. So, some cases it is difficult to go near the as prescribed distances. In such cases polymers or polymer type substances are employed or used for effective cleaning conditions, which also will help in the wind or high windy conditions. To provide proper mixture ratio, it is also important to follow the manufacturer guidelines for adding the polymers to the water system. The quantity, type of polymer or a substance before it is being added is to follow the proper manufacturer's guidelines. When these additives are done, it is finished with the polymer mixture, it is to be ensured that properly flush the water system before storage. So, this water has to be clear before the system is being employed for the cleaning activities. So, the water along with the polymers have to be properly mixed, and it should be used effectively for the cleaning purpose. This is about various additives which are to be used, which are not to be employed for the cleaning purpose with the water. Next is the monitoring of the cleaning systems. This is a equally important aspect for the utility engineers. Here various continuous testing or monitoring systems are available to measure the resistivity or the conductivity of the water which is being used. So, continuous monitoring is essential to check for better performance. So, whether characteristics of water are known or unknown, each tank full of addition should be tested. So, any time the contaminants could be affected to the water. So, the water has to be tested before it is being used, and the minimum standards must be maintained for safety aspects while using the cleaning methods either in energized or for the de-energized conditions. The water resistivity decreases as the water temperature increases. So, non-temperature compensated testers should be used for checking this resistivity also, because the water which is stored for a long period of time, it could the resistivity change, and it has to be tested before it is being applied. A common practice is generally to dump the water tanks after use and refill with fresh tested water the next day or the next operation for the cleaning aspects. So, this has to be followed, else the water which is left should not be used again and again, so that there could be a change in resistivity of the water because of the contamination. So, proper common practice is generally to be followed, and continuous monitoring systems generally usually require a probe within the tank, where a probe or probes constantly measure the conductivity of the fluid or the water from the tanks for better monitoring. So, this also will give a better system or a better information of the water quality. So, a light or audible warning and pump throttle control can be integrated into the monitoring circuit also in case if it is required. In general, a 12 volt DC actuated systems are preferred to AC industrial devices that require an AC DC inverter or converters to give information about the noise or a little light mentioning about the activity or the pump for the water monitoring systems. So, this also are being used. So, the quality of water, the contaminants and also the monitoring is very essential, as the contaminated water should not be employed for cleaning, where these could leave the traces on the surface, and the performance of the insulator may not be improved even after the cleaning aspect. So, care has to be monitored, and also the safety is utmost important in case of the live line washing methods being employed. We look into the technical consideration in particularly for energized cleaning with water. So, what are the technical considerations which can be looked into apart from the quality of water, the measurement of resistivity, the measurement of conductivity or addition of the solvent, so on. Here one of the important aspect being the leakage current which is of importance. Here the leakage current, which is defined as the current that flows through normally non-conducting elements such as hose which is being used, water hose, the pipe and the water hose. These details of the leakage current and the particular information is described in the IEEE standard and IEC standard as mentioned, where it gives the minimum values of the leakage current for the hoses and the equipment which is being used for the cleaning for energized conditions. So, for safe values the let go current for an average person also is to be considered. Here the level of 1 milliamp is the approximate perception threshold current that a person detects as a slight tingling sensation in his hands or fingers due to the current flow. So, when the leakage current flows through the nozzle or the hose, care has to be taken and ensure that when the nozzle is properly grounded with the braid, that is a copper braid is properly grounded, no appreciable leakage current should flow through a person's body during the washing operations. So, the current which is being leakage current has to be flowing to the ground, not to the body of the person. So, nevertheless sometimes a person should anticipate the possibility that nozzle grounding braid can accidentally open or become disconnected. In such cases proper arrangements, care or safety measures are to be employed. For this reason the leakage current in the wash stream should be limited to 2 milliamps. So, this is the worst conditions where the connectivity of the ground using the copper braid can accidentally come out, open or becomes disconnected. In such cases also the current should not increase more than 2 milliamps. So, the washing equipment, the wand, the structure, the washing person should be at the same potential, that is to be noted. So, the person who is standing at the tank arrangement where is being used for cleaning the insulator during live line condition have to be at the same potential, so that the rise in potential is not seen and the safety of the personnel who is cleaning the insulator has to be taken care. So, these details further are very clearly explained with reference to the IEEE standard 1048 about the grounding of the hose pipes, the currents to be contained and how it is to be done is described. So, further information is available. So, you can read the standard for more details about the grounding aspects particularly for the nozzles and the hose which is being used for the cleaning operations. How the in substations, that is about the transmission part. In substations these nozzle operators generally use handheld nozzles. They wear rubber shoes, rain cloths or rubber gloves to avoid getting wet. So, this has to be taken care. In case the surface person becomes wet, the conduction happens and this has to be avoided. So, proper clothing and proper gloves have to be used. In addition, the wet hose which is in direct contact with the ground, the operator has both hands on the nozzle while the stream is contacting energized equipment. So, it should not be difficulty under these circumstances to limit the leakage current by adjusting a washing distance. So, the distance is very important, the pressure of the water spray, the orifice, that is diameter of the nozzle set and the water resistivity. Several of these things have to be adjusted to see the person does not get contacted with the or current flows through the body of the person. So, the parameters that influence the leakage current in the washing water stream are the line voltage important, what is the voltage which is being the insulators are being cleaned, what is the voltage level the equipment is being operated, the distance from the nozzle tip to the energized part, this is a very important point. Water resistivity or the conductivity which is being used, what resistivity or conductivity plays a role, the water pressure, operation of the water jet which is being used at a certain pressure is also an important parameter which could influence the leakage current, and the nozzle or orifice diameter. So, nozzle diameter which is being used, this also plays an important part in the influence of leakage current. So, as mentioned earlier, currents leakage currents which are exceeding 1 or 2 milliamps are to be guarded against by using water that falls within the acceptable range of conductivity or resistivity, replacing worn nozzles or carefully maintaining the safe working distance. So, these points have to be considered to see that the leakage current do not flow or leakage current is being contained by using the methods. This table gives the information about the minimum distance where a personal or the cleaning is to be done, in particular during the energized washing or cleaning conditions. The working distance, minimum distance to be employed here. Earlier also we have looked into this similar arrangement. So, depends upon this gives the line voltage for various voltage levels. This is the minimum nozzle to conductor distance for the cleaning, minimum water resistivity, the minimum nozzle pressure to be adopted, and the maximum orifice or the diameter in millimeters. So, a few considerations here. In case of 13 kV and below, you can see the minimum nozzle to conductor distance should be maintained at 1.82 meters. The minimum water resistivity is 1300 ohm centimeters. The minimum nozzle pressure to be 207.58 kilopascals, and the maximum orifice diameter is 4.76 millimeters. So, here you can see most of the voltage levels as increases, the minimum nozzle to diameter of the conductor varies, but the minimum water resistivity is maintained same. You can see it is 1300 ohm centimeter in whatever voltage levels. Similarly, the minimum nozzle pressure, you can see it depends on the voltage, it is not depending upon the voltage levels, it is maintained at a particular pressure as the insulators have to be cleaned. And maximum orifice diameter also changes as the voltage levels. You can see various type of nozzles of diameters are being employed. So, this table gives an importance information. As the voltage level increases, a similar pattern is being observed for further 400 or 765 kV transmission systems. Similar distance have to be maintained, which are also given in the standards. So, working distance is very important, care has to be taken, safety is of utmost importance in the cleaning of the insulation. The table 4 here shown gives the minimum distance again for the energized conditions. Here further voltages above 345 kV are shown here, line voltage 345, 500 and also 500 kV DC is being given here. So, you can see here again the minimum nozzle to conductor distance has to be maintained in meters. This is the minimum water resistivity which has to be done. Above 400 kV the water resistivity changes, and here you see the minimum nozzle pressure changes after 400 kV or 345 kV. Further there is a change in the pressure and also the maximum orifice diameter changes depending upon the voltage level and the surface conditions. So, point to be noted here, up to 345 kV distances were generally interpolated using a 230 kV and 500 kV and are found to be in line with the industry practice. So, most of this the feedback which have been taken from the industry, the guidelines have been set for cleaning. So, the distance is generally limited by the tower dimensions and the configurations. Because of the limited nozzle to conductor distance, demineralized water with a resistivity of 50,000 ohm centimeter or greater can be also employed for the cleaning. One such example is for 500 kV DC and 500 kV AC, which is shown here. So, this is typically because of the nozzle to conductor distance which is employed. So, changes could be done the instant where it is being used. So, this is the generalized procedure or the methods which are being employed. Locally, some minor changes depending upon the manufacturer's information can be utilized for proper cleaning. So, various contaminants which we have described, the summary of this contaminants type and also the washing or cleaning types which are used. You can see various contaminants we have discussed. This is the water washing, various types, either low pressure or high pressure type of washing, compressed air dry cleaning using the corn cob or a walnut shell or carbon dioxide pellets, or sometimes wiping using the cloth. It could be hot wiping or a hand wiping. So, several methods are being used for cleaning the insulators both for dry and wet conditions. So, you see the various contaminants which are given here like the salt, cement, lime, earth dust, fertilizers, metallic dust, coal dust, volcanic ash, bird excretions, chemical smog because this is a vehicular pollution, then cooling tower effluents, smoke or the coal soot which is coming from the coal plants or organic or ice or snow, and petroleum or grease. So, for all these contaminants, the procedures are being shown here, the adoption for cleaning methods using various types of methods, either dry cleaning or dry washing or water washing or wiping methods are generally used. So, this gives the summary of the contaminants types and the washing methods to be employed in case of various contaminants, very important information. So, that completes the cleaning procedures employed for the insulators both for ceramic and polymer types, methods and also the techniques employed, the distances to be maintained, various types of arrangements which have been followed. Further, we will discuss about the coatings for the insulation on ceramic as well as the polymer insulators further. Thank you.